second grade friends. How are you guys? I miss you all so much. Now that we are going to do video recordings of lessons, I'm going to introduce some new stuff in science. Okay. Throughout second grade, we've done a lot of life science, learning about animals and their habitats. We've done a whole lot of earth and space science when we were talking about landforms and bodies of water. And starting today, we're going to start to learn about physical science. And we haven't done physical science since kindergarten. So we're going to do a little bit of a review, very quick, and then I'm going to introduce this new part of physical science to you guys. Okay? So, if you look at this word right here, you've all seen it before. It says forces, right? And we know from kindergarten that there are two types of forces. I wonder if you guys remember what they are. I'll give you a second. Both words start with a P. The first one is push. And the second one is pull. Right? Those are the two types of forces. Everything on the planet can either be pushed or pulled. And there's little pictures here. There's a kid pushing the car, and there's a boy pulling a wagon. And we know that some objects can do both. They can be pushed and they can be pulled. Like a vacuum. When you're vacuuming a rug, you have to push and pull it. So this new part of physical science that we're going to be learning about is this word right here. Friction. Okay? Now before we go any further with this word friction, we're going to be looking at the way it's spelt. Okay? Because I don't want you to get mixed up with another word you know very well, fiction, without the R, right? If we take that R away, it says fiction. And in reading and RTI, you guys talk about fictional stories all the time, right? This word is slightly different in the way that it's spelled, but it's totally different in the world of learning, okay? Friction. Say that, friction. Okay. I'm just going to leave this down here for now. Let's use our hands to talk about what each of these words mean. And I know we don't know what friction means yet, but you will in a second. All right, take your hands and I want you to push them together, right? You feel that? You feel the palms of your hands pushing together? Okay, now with your hands, I want you to pull them apart. And you can do this with your fingers. You can pull like this. You can pull like this. Notice that force, pulling your hands apart. All right, so what can we do with our hands that will create friction? What do you guys think? Some of you might know. What if you went like this? Clap your hands together, keep them flat, and then rub them. And I want you to squeeze your hands together like you're pushing when you rub them. Push, 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 and keep going. Try to go fast. Don't stop. We're going to do this for like another 20 seconds, okay? The space in between your hands, it might start to feel warm. That feeling is friction happening. Is it getting harder? Is it getting harder? All right, stop. Do you feel that? That's friction. Okay. All right. So I moved push and pull down more to the bottom of the board because we know what pushes and pulls are, right? That was just a quick review. I moved friction right here in the middle so that you guys can see it. All right, because this is that new part of physical science that we're going to be talking about for the next couple of weeks, okay? Friction is what happens in between two objects, right? Like your hands, those are two objects, or an object and a surface, right? Like my hand and the floor is a surface. Friction is what happens in between two things, basically, when they rub together. Okay? So I want you to take a second right now. And besides your hands, besides your feet and the ground, I want you to think of two other places where there could be friction. Right? Think about it. Think about inside your house, outside your house, at the playground, at school. Where is there friction? Well, the answer is there's friction everywhere, right? Whenever your feet touch something, whenever your hands touch something, whenever two objects touch each other, right, there's friction going on there. And that's why we're not slipping and sliding all over the world all day long. Okay, it's because of friction. All right, guys. So I moved those vocabulary words out of the way. And what I did was I put up this poster. And the poster has a question at the top and it has a question at the bottom. We'll worry about that one later. But what we're going to do is we're going to practice making some predictions about this new word friction and what it means, what it looks like. Can there be more of it? Can there be less of it? Okay? Now, before we get started, remember that when you make predictions, it doesn't matter if you're right or wrong. Okay? You just want to try your best. Think about all that information that you have up here in your brain to make the best possible prediction, but it doesn't matter if it's wrong. Okay? All right. So the question is, when is there friction? And there's 3 pictures here, so we have to decide if there's friction in these pictures. And when is there friction? Okay? So the first one is a boy, and he's sliding down the slide. And the description for this drawing is when the boy slides down the slide. Okay? The second picture is a boy, and you could see he has his knees bent, so his feet are on the slide. Okay? And it says when the boy sits on the slide. So think about that. I know you guys have all sat with your feet on the slide before. All right, and the last photo is the boy doing both of those things. He's sliding, and then at the end, he puts his knees up again and his feet on the top of the slide. And the description says, when the boy slides down and sits on the slide. Okay? I want you guys to take a second and just think about it. When is there friction? All right, so now before Ms. Millerick explains her own ideas, I want you guys to make sure that you shared your prediction out loud with somebody. And even if there's nobody next to you while you're watching this video, maybe you just say it out loud, right? Where is there friction? When is there friction? Are you ready? The answer is, there's no real answer. There's friction happening in all 3 of these drawings, okay? When the boy slides down the slide, this first one, there's friction between his pants and the slide. There's not a lot of it, but there is a little bit of friction. Same thing here. When the boy bends his knees and he puts his feet on the slide, there's some friction rubbing between his pants and the slide, right? There's not a whole lot of it, but there is friction. The best possible answer would have been the last one, right? The most amount of friction is happening here. It probably took him the longest to get down the slide when he did it this way, right? Because he slid and then he also did the whole bending of the knees thing. But, you know, what are you guys thinking? It didn't really matter which one you chose because there is friction happening in all of them, just different types of friction, okay? So coming back to just this word friction, right? Remember, there's an R there, friction. Friction is a force, like pushes and pulls, that slows things down, basically. Okay, so when we start to explore friction over the next few weeks, we're really looking for, when is there friction that slows the object down? Okay? All right, guys, so just like we do every time we learn about new topics in science, we're going to explore together. All right, so we're going to explore some friction. I have this model of a ramp set up here, and there's 2 different spaces. So in those 2 different spaces, you could put different surfaces. It's really neat. So the first 2 that we're going to do are this purple and this blue one. The purple one, they're all raised, right? All of the surfaces, but the purple one is squiggly lines. Okay, so I'm going to put that in the first lane. And then the blue one is these X's that bump up. All right. And then I have a toy car. And we're going to see which surface has more friction with the toy car, right? Which one is going to either slow down or stop the toy car from moving down the ramp. And why don't you guys take a second to make a prediction? What do you think? Is the purple one going to slow down or stop the car? Or is the blue one? Which one's going to have more friction? All right, ready? We'll do the purple one first. I'm going to put the toy car on top. And look at that. It wasn't perfect, but it did go all the way down the rail, right? Let's try it with the blue one now. It's not even moving. I'm gonna give it a little push. All right, so it went down, but it wasn't pretty. I think that the blue one had more friction. The car definitely had a hard time going down the blue one. All right, we'll do another test run. I have different surfaces. We will try out this yellow one, which is lines that go across it and they bump up. And then we will try this red one, which is very similar, but they are squiggly lines that go across it. All right. Why don't you guys make a prediction? Which one's going to have more friction with the toy car? I'm gonna go with the red one this time. Okay. Let's see. Toy car on. Okay, again, it went all the way down. Took a little bit, but it did. Huh. I don't know. Seems like the same thing happened. Let's try it again. Ooh, what do you guys think? Which one has more friction? The yellow ramp, because it stopped the car completely. All right, so before you get started on the follow-up activity where you are going to explore friction a little bit more on your own, I want to just recap the definition of friction, okay? And I want you guys to write it, because we do that in second grade. Whenever we learn about a new word, we write its definition, okay? So I attached a little template where you could do your writing, or if you have a little science notebook going on, you could do it in there. But what is friction? Here is our second grade definition, okay? Friction is a force that happens between two objects. It can slow down or stop the objects from moving, okay? So I'm gonna pause this. You guys can take as long as you need to write the definition, and then you can get started on your own little exploratory investigation, all right?